Hey everyone, welcome back. So till now we have solved problems based on map containers, multi-map set and multi-set containers. Today we are going to solve more problems with the combination of containers like queue and stack, queue and map, because sometimes you have to use multiple containers to solve a single problem. So let's get started. So our first problem is reverse a queue. You already know what is a queue. It is a single-ended queue, right? You can insert element from the back and can remove element from the back. So we have a queue like this. Now the question is, you have to reverse the queue like this. We have already seen how to reverse arrays or vector. We reversed vector using reverse function. Also we used our custom reverse, right? But this is not an array, this is queue, so we cannot reverse similar to the vector or arrays, right? So to reverse our queue, if you are thinking if you can run your loop from last index to the front, you cannot do it, right? Because in queue there is no indexing, so you cannot access the element with the index number. So in this case we only had an option of queue dot front and queue dot pop. We cannot reverse our queue with only queue itself. We have to use another data structure which is stack, right? Okay, let's see how this is our queue. In queue you can insert or push from the back, look from the front. So now let's take stack. If you can pick a value from the front and insert it into the stack, then after picking it up you can pop it from here. Now your 2 will become your first element in this queue, so you will pick the 2, then insert into the stack, and then you will remove it. Now your first element become 3. Now you pick the 3 and insert into the stack, then you will remove from here, then you will pick the 4 again and insert it here. Now what is the property of stack? You can insert from the top, also you can remove from the top, right? So if you remove from the top, you can see the sequence. First you will remove 4, then 3, then 2, then 1. So here you can see it is our reversed order. Okay, so what's happening here? First we have a data in our queue. Okay, we have data in our queue. We cannot directly reverse in the queue, so we will be taking a help of stack. Okay, so we will insert one value at a time, 1 2 3 4 5, then we will start picking value from the top, then it will print in the order of 5 4 3 2 1. So this will be our output. Okay, so to reverse a queue, we have to take the help of stack. So in this question, we are using two containers, queue and stack. You may be thinking why we are not using vector or array. We can use, there is no problem, but sometimes there may be a case where interviewer asks you have to reverse your data using queue and stack only. So in that case you cannot use vector or array, you have to use the thing which he provided. Okay, now let's write our code. So first we have to take n number of elements, then we declare our queue in which we are going to insert our elements. So we will run our loop I less than n I plus plus, and queue is also not a indexed based, so we cannot directly insert. So first we have to declare a temporary variable, then we can write queue dot push of x. Okay, that's how we are going to insert into the queue. Then we will declare stack. Okay, in this case our stack is auxiliary space, right? Because we are using for solving our problem, means we are reversing our data. Now we cannot use loops in the queue, so we have to check if queue is not empty, means our queue is not empty, means there is some elements. If there is some element, we will pick that element from the queue. Okay, so this is our queue, we will pick this element and store in the x. After storing in the x, we can easily remove this value because we already stored somewhere, so we will remove 1. So I can write q dot pop. Now I can store this value in the stack. Okay, so first I picked a value from the queue, then removed from the queue, then inserted into the stack. Okay, in this way you will be able to insert all the values in the stack. Okay, this is the only way, so you should remember this because in the future you will be using more frequently. Now we know we have our data in this order. Now we have two options, we can directly print or we can insert back into the queue. So our question was reverse a queue, right? so we have to insert our data back to the queue. So we will write loop again, while this time for stack st.empty. If stack is not empty, we will pick the top element from the stack, then we can remove that element and insert back into the queue. Okay, you can see both of them are similar. One is for the queue, one is for the stack. Now to print our queue, we will write while not queue dot empty cout equals to queue dot front, because we have a value at the front, then space, then here queue dot pop. Okay, after printing every first value, we will remove that front value also. If you print one first and if you don't remove it, it will keep printing one for an infinite time, because it is checking for the not empty. As long as our queue is not empty, the keep will running, and if the queue is empty, our loop will stop. So basically queue empty. Okay, so it will first check our queue is empty, no, right? So the not sign will convert to the yes. Yes means true condition, true condition means loop will continue. If in some cases our loop will become empty, means true condition, then true with the not, it will become false, then false means our loop will stop. Okay, it's kind of reverse psychology. Okay, means we are saying empty then true, true is not true, then it will become false. Okay, remember this. Or there is another way to write it. Q dot size greater than 0 means if there is still some elements in the queue, then its size will be greater than 0. So in that case also our loop will keep running. Okay, so let's write our code so you will be able to understand it. Okay, so first let's remove it. Let's keep int and cname. Okay, now let's declare our queue. Now we will run a loop to insert a value into the queue. Int I equals to 0, I less than n, I plus plus. Okay, because we are running our loop n times, then we will declare a temporary variable which will be storing values, then we are pushing that value into the queue. Okay, now we will declare our stack which is going to store values temporarily. Now we cannot use our for loop, so we will write while queue not empty. Okay, if our queue is not empty, we will pick our front value, then we can easily remove it from the front, then we can insert into the set. Okay, now we are going to use same loop again and again. After inserting into the stack, we have to insert back to the queue itself. So this time we are inserting into the reverse order. So if we already know we are inserting into the stack, so the stack order is already in reverse, so we have to pick value from the top and insert into the queue. So this time we are writing for the stack, then there st. For stack we will write here top, here also st, then here queue. Okay, now let's print our queue. So we will be using our loop again. So cout x, then spaces, we are not pushing, so let's remove it. Okay, this is our whole code. So first we are taking input into the queue, then we are inserting into the stack from the queue. After inserting, we are inserting back to the queue from the stack, then we are here printing our queue. Okay, now let's run it. So first we will give number of values 1 2 3 4 5. Here you can see it is printing me in the reverse order. Okay, so also you can write like this here, queue dot size greater than 0 means size of the queue 1, the loop will run. If the size of the queue becomes 0, the loop will stop. So this is also the way to write condition, right? You can write any condition as long as it is true when we have elements and false when there is no elements, right? So here you can see it is printing me the output. Okay, so whenever you are going to solve problem, you are not going to solve using single container. In most of the cases you have to use more than 2 3 4 any number of containers. Okay, let's look at one more problem. So our question is first non repeating character in a stream. Let's say we have a stream of data like this, means this data is continuously coming. Okay, and it is asking to replace the repeating character with the -1, means here we have a b c, so we can say A is repeating character, so what is saying, only write unique data and for the repeating replace with the -1. Okay, so this is our stream of data and it is asking for the non-repeating character. If there is repeating character, replace with the -1. Okay, so let's take another example. Like if you have A, B, A, C, D, D, E. If you have a stream of this data, what you have to do, your output will be A, B. Here you can see A, B have already seen, so we will write here -1. Then C, D, then D comes again, but we already seen the D, so we will write -1. Then E. This will be our output. Okay, so this is our Q. Now we cannot directly check if we have already seen A or not, right? As a human, we can detect these are similar, but computer cannot detect until or unless we are specify or we ask him to compare the data. But we are not going to compare every single data. In this case, there is one data structure map which can store data with the frequency, and we can use map container to find if that data is already exist or not. Okay, let's take an example. So this is our queue. Let's take a map. So first we will start from here. We will look at the front element, then we will insert into the map with the frequency of 1. Okay, so in this case we will print our A. Now A will be removed from the queue, right? Because we are using queue, so it is not indexed based. Now at B we will insert B also with the frequency of 1. We will print B here and remove B from the queue. Now we are at A. It will find in the map it already exists. That means we have already printed our A. So we will print this time -1. So here we will print -1. Then at C, C is not available, then we will print C. Then D, D will print also included in the map. Then D will comes again. You can see D is already available in the map. We can write here -1. Then similarly with the E. So in this case, okay, one more thing, we can also increase our frequency. Okay, so in this case our map is working as a memory container, means it is storing the data and telling us you have already seen that data. So let's write our code. Okay, let's remove all of this. Okay, so we will take n number of elements. We will take q. This time we are not taking as a integer, but we are taking as a character. Also we will declare our map which will be storing character and their frequency. So we will name it frequency and we will run our loop I equals to 0, I less than and I plus plus. Okay, so we will temporarily take our character in the ch variable and character into the queue. Okay, now we will run another loop into the queue dot not empty. Okay, then we will pick our first character ch equals to q dot front, right? Then we can pop from the queue. After this we will check in the map if that value is available or not. So we will write frequency dot find ch if not equals to frequency dot end. Okay, if it is able to find our character into the map, that means we have a repeating character. In that case we will be printing our -1. Okay, else we will be printing that character. Also we will include that character into the map also, right? So what we are doing here, we are taking n elements into the queue. Here we are running loop checking if queue is empty or not. So we will starting from the first element. We are picking the first element, then removing it from the queue. After that we are checking if that element is available or not. If that element is available in the map, that means we have a repeating character, so we will print -1. Else that element is not available in the map, we will print character itself. After checking, we will add that character into the map, means initially there is nothing in the map, so it will print our character. Also add that character into the map, because we have to keep the track of the character for the future, right? Because the first time A comes, we will print it and store in the map. Then if the A comes second time, we will check in the map it is available. We will just increase the frequency into the map. Okay, now let's run this so it will be more clear. So first we will take 7 number of characters, then A, B, A, C, D, D, E. Here you can see A, B, then -1 because A, B have already printed, then C, then D, then again -1 because we have already printed D. So this is our output. If you want, you can also not print -1, so it will only print our unique data also, right? So let's leave it here. You can try it by yourself, right? So here we are using map as a memory container which is keeping track of all the characters we have seen till now, and we are using to solve our problem. Okay, so today's problem is kind of complex compared to previous problems, but they are still basic. There is more such problems or more complex problems than these are. So until then, thank you everyone, have a nice day.